Have you ever driven across a bridge that hasn't rusted in decades, touched a galvanized steel railing, or used a battery without ever wondering what invisible metal is silently protecting and powering all of it? Zinc surrounds us everywhere, in our medicines, our electronics, our construction materials, and even inside our own bodies, to the point where modern life without it seems completely unimaginable. But how does humanity extract this remarkable bluish-white metal from deep within the earth and transform it into one of the most essential materials in human civilization? Today, we're uncovering the fascinating story of zinc. What it actually is, what makes it so uniquely useful, and why it has become the fourth most consumed metal in the entire world. So let's discover this remarkable transformation right here on No More. Zinc is fundamentally a bluish-white metallic element with the chemical symbol Zn and atomic number 30. What makes zinc truly extraordinary is its exceptional anti-corrosion property. When applied to steel or iron, zinc acts as a sacrificial shield, corroding itself first to protect the metal beneath. This process, called galvanization, is why countless steel structures around the world remain rust-free for decades. The manufacturing process centers around mining zinc-rich ores, chemically processing them through roasting and leaching, and finally refining the pure metal through electrolysis. Not every ore source proves equally suitable for zinc production. The most important zinc ore is sphalerite, a mineral containing zinc sulfide, which typically holds 60 to 62% zinc content. High-quality deposits must contain minimal impurities like lead, cadmium, and iron, which can complicate the refining process. Zinc deposits are found worldwide, and with major mining operations in China, Australia, Peru, and India. After extraction, the raw ore undergoes crushing and concentration to separate valuable zinc minerals from waste rock, a process called beneficiation. The concentrated ore, called zinc concentrate, typically contains around 50 to 55% zinc before entering the smelting stage. Humans have been using zinc for over 2,500 years. Ancient Indians and Chinese civilizations used zinc alloys without fully understanding the metal itself. In 13th century India, pure zinc was first intentionally smelted, making India the world's earliest zinc producer. Modern zinc production was revolutionized in the 20th century when the hydrometallurgical process, using electrolysis to refine zinc, became the dominant global method. Today, over 80% of the world's zinc is produced using this highly efficient electrochemical technique. The zinc concentrate first enters a massive roasting furnace, where temperatures reach approximately 950 degrees Celsius. At this intense heat, zinc sulfide reacts with oxygen and converts into zinc oxide, releasing sulfur dioxide gas as a byproduct, which is carefully captured and converted into sulfuric acid for industrial use, minimizing waste. The resulting zinc oxide then undergoes leaching, where it gets dissolved in dilute sulfuric acid to create a zinc sulfate solution. This solution passes through a rigorous purification process to remove impurities like copper, cobalt, and cadmium. Finally, the purified zinc sulfate solution enters large electrolytic cells where electric current is passed through it. Pure zinc deposits onto aluminum cathode plates while oxygen releases at the anode. The deposited zinc sheets are stripped from the cathodes every 24 to 48 hours and melted in induction furnaces, producing zinc ingots of 99.99% purity. After production, the zinc undergoes strict quality testing to verify its chemical purity, physical properties, and compliance with international standards. It is then cast into ingots, rolled into sheets, or alloyed with other metals like copper to produce brass, one of humanity's oldest and most versatile alloys. Beyond galvanization, zinc finds critical applications in decasting for automotive parts, sunscreen lotions, dietary supplements, and even agricultural fertilizers, where zinc deficiency affects crop yields worldwide. The shiny metal that emerges from this complex process may seem ordinary, yet it represents thousands of years of metallurgical discovery and industrial refinement. From ancient Indian smelters to modern electrolytic refineries, zinc continues to silently protect, strengthen, and sustain the infrastructure of our entire civilization. The next time you cross a bridge, hold a galvanized railing, or take a zinc supplement, remember, you're experiencing the result of a remarkable journey that transforms ore from deep within the earth into one of humanity's most indispensable metals. Thank you for watching No More. If you have suggestions for our next video, feel free to share them in the comments below. We'll make sure to give you proper recognition. Don't forget to like, subscribe, and stay tuned for more fascinating stories, discovered through the smallest details.